To practice quiz chapter 19, quiz 1. We have the 1 meter long wires carrying a certain amount of current. The wires placed perpendicular to a magnetic field of strength 0.2 Tesla. If the wire experiences a force of 0.6 newtons, what is the magnitude of the current moving through the wire? So we have the wire, and this is 1 meter. Okay, we know that the magnetic field is perpendicular, so it's either into the page or out of the page. I'm using this as the X, so for it to be 90 degrees, it would be out of the page for simplicity. And then, let's see, and we know that that is 0.2 Tesla. 2 Tesla. And then we have the force is equal to 0.6 Newton. So the equation we have for this would be the force. I'll give you a cheat sheet. I'll hopefully get a cheat sheet done later today or tomorrow, and I'll email that over to you with some of these equations and stuff. So the force is equal to the magnetic field times the current times the length of the wire. And what we're trying to do is we're trying to find the current. So we know the force, we know the magnetic field, and we know the length of the wire. So then that will give us the current. So we're basically, once you know and it helps to write everything out, basically draw. It seems kind of corny, but it does help. Draw the wire, draw the magnetic field. We know the length is 1 meter, 0.2 Tesla, and 0.6 Newton. And then just grab the equation and make it as simple as you can on yourself. Whoops. Sorry, I'm getting ahead of myself. So it's force divided by the magnetic field times the length of the wire. Length of the wire is 1, so that makes it easy. So it's basically 0.6 divided by 0.2, which gives us 3 amps is our answer. Because 0.6 divided by 0.2 is 3, and then the unit, since we're dealing with Teslas and newtons and meters, it is already in amps. So that makes it pretty simple. So again, just kind of drawing out the information we are given, finding the equation, the simplest equation we can, and then we know we have the force, we know we have the magnetic field, we know we have the length. It's just a matter of finding that, and it then becomes an extremely simple problem to solve. It's just, multiplication and division, and then we're multiplying by 1, so it really gets simple. Now, if this magnetic field, and I don't know if you'll have any questions like this, was at an angle, let's say it was coming out at 30 degrees, this would actually have a sine theta, which is the angle, whoops, which is the angle. But since the angle is 90 degrees, sine 90 degrees is equal to 1. So that's why we don't have that. This is actually just equal to 1 at a 90 degree angle. But if it were 30 degrees or something like that, then it would be, we'd have to multiply by this factor as well. But since they're perpendicular, 90 degrees, sine of 90 degrees is 1. If it's not 90 degrees, then you do have to add this component to it. Actually, this is the correct equation, but 90 degrees, sine of 90 is 1. Okay, I hope that helped a little.